Ever heard of a fruit that changes shape? One that's constantly on the move, its pieces like splitting apart and colliding over millions of years?
Mm.
Sounds strange, right?
Yeah.
Well, that's kind of the wild journey we're taking you on today. A deep dive into plate tectonics
Okay.
and how this constant dance of continents has shaped like all the incredible life on Earth, the biodiversity.
Fine.
So get ready for some serious aha moments as we unearth the secrets beneath our feet.
I'm ready.
Our expedition, it begins with a scientist, Alfred Wegener.
Oh, yeah.
Back in the early 1900s.
Yeah.
He had this totally revolutionary idea.
Okay.
He dared to suggest that the continents, they weren't fixed, they drifted across the Earth.
Wow.
Can you imagine trying to pitch that over 100 years ago to a bunch of skeptical scientists?
That's a tough sell.
Talk about an uphill battle.
Yeah. It was a pretty bold theory. Not everyone was exactly lining up to endorse it.
Right.
To understand, I think, why it was so groundbreaking, we need to go to the Earth's core, so to speak.
Okay.
Picture the Earth as this, colossal sphere made up of layers.
Mm-hmm.
The outermost layer, the one we live on, that's the Earth's crust.
Right.
And it's actually surprisingly thin,
Really?
especially compared to what's beneath it. Think of it like the skin of an apple.
Oh, okay.
Just this delicate layer encompassing the entire fruit.
Okay.
And below the crust, that's where the mantle is.
Okay.
It's way thicker,
Mm-hmm.
and it churns with this consistency, almost like molten rock.
Molten rock.
And here's the key thing. The crust, it's not a single unbroken shell. It's fractured into these massive pieces. We call them tectonic plates.
Okay.
And these plates, they kind of float, if you will, on that semi-molten mantle.
So these tectonic plates, they're like giant puzzle pieces,
Except
making up the Earth's crust.
Yeah.
That's quite a visual.
it is.
I bet those pieces were Wegener's first clue, right?
Oh, absolutely.
You can't miss how the continents, look at South America and Africa, they
Mhm.
practically fit together like pieces from the same puzzle box.
Yeah, you're right. But Wegener, he didn't stop at just appearances.
Okay.
He dug deeper and found some pretty compelling evidence
Like what?
in the fossil record,
Okay.
specifically the Lystrosaurus fossils.
Lystrosaurus.
Yeah, they were these land-dwelling reptiles.
Okay.
They lived millions of years ago.
Millions of years.
And get this, they're fossils. They've been found on continents now separated by oceans.
No way.
South Africa, South America, you name it.
So how'd they cross the ocean?
That's the thing, right?
Ah.
It's hard to imagine a reptile paddling across the Atlantic.
Yeah, right.
This suggested to Wegener that these continents, they were once connected,
Wow.
providing like a land bridge for these creatures to roam freely.
You know what's really wild to me? Wegener, he wasn't even a geologist.
Really?
He was a meteorologist. Weather patterns, clouds, the atmosphere.
Right, interesting.
What would make someone in that field even think about continents moving?
That's why.
It's like next level thinking.
And the clues, they didn't stop with just ancient reptiles.
Oh, really?
So
Wow.
picture this. You're trekking through Brazil and you stumble upon this rock formation.
Okay.
And it's practically identical to one thousands of miles away,
Yeah.
like in the Scottish Highlands.
Wow, seriously?
Yeah. That's what Wegener found, essentially.
Right.
Similar formations. On opposite sides of the Atlantic, the Earth was whispering secrets.
It's like secret messages encoded in the continents.
Right.
So we've got matching continents, we've got the fossils, and now the rocks too.
Exactly.
It's like a giant game of find the pairs, but on a planetary scale.
Yeah. And Wegener, he found another piece of the puzzle, too.
Oh, there's more?
Climate clues.
Okay.
He found evidence of glaciers, right?
Okay.
But in places that are, crazy hot now.
What, like deserts and stuff?
The Sahara Desert, for example.
The Sahara! No way! Ice there!
That's what the geology indicates, yeah.
Yeah. Wow, so it wasn't always a desert?
Right. It means those land masses, they weren't always where they are now.
They must have moved a lot.
Over millions of years, yeah.
Wow, talk about a change of scenery. It's wild to think about, the Earth looking so different millions of years
That would
ago.
have been a completely different world.
Oh, Wegener, he had the puzzle pieces, right? He had the fossils, the rock formations, and the climate clues. It's a lot.
Pretty convincing, right?
Right. But people back then still didn't buy his theory of continental drift.
It was a tough sell.
What was so hard to accept?
Well, he could explain how the continents move.
Oh, right. They just, drift.
He thought they plowed through the ocean floor.
The ocean floor.
Yeah, But that didn't really make sense, with what people understood back then. It wasn't until much later, like decades, that we had better science, like about the Earth's interior and seafloor spreading.
Ah, so that's when Wegener was finally proven right.
Exactly.
It's wild how science works, always changing,
Right.
always finding new evidence.
It's a process.
But what's crazy to me is that this continental drift, right? This thing happening beneath our feet,
Mm-hmm.
it's not just about geography.
What do you mean?
It's like the reason we have all this amazing life on Earth.
Biodiversity, you mean?
Exactly. It's crazy, right? Like millions of species. I mean, everything from tiny bacteria to huge blue whales, all on this one planet that's constantly on the move.
It really puts things in perspective, doesn't it?
And we know you love those aha moments. And
Mhm.
trust me, this connection between like the ground and all the life up here, it's mind-blowing.
It really is. Like, the Earth is this huge tapestry
A tapestry.
with all these threads of life.
Okay. Yeah.
And plate tectonics is like the loon constantly weaving and changing the pattern.
So how does that actually work, though? Like, how does continents moving actually make life, appear and change?
Imagine the continents as these kind of like life rafts, right?
Okay.
Each one carrying its own, like, passengers, the plants and animals and all.
Right.
And as they drift around, bump into each other, it's like it mixes things up.
Oh,
Species mingle or they get separated, and that's where things get interesting.
that makes sense.
Take, for example, the Malay Archipelago.
The what?
The Malay Archipelago, it's,
Is that like Indonesia and all those islands?
yeah, exactly. It's like a
It-
perfect example.
With the Komodo dragons and stuff?
And orangutans, yeah, all those cool creatures.
Right.
And it's all thanks to plate tectonics, really.
Really? How so?
Well, it sits at a crossroads, right, where continents have been bumping into each other for millions of years.
Oh, I see.
So you've got species from Asia mixing with those from Australia, total biodiversity hotspot.
It's like a mixing pot of evolution.
Exactly. And speaking of unique creatures, remember the dinosaurs?
Oh, yeah.
Plate tectonics, it played a big role in their story, too.
Because they were around when it was all one big continent, right?
Exactly. Pangaea, they could roam freely.
Right, Pangaea.
But then as things split apart, you got dinosaur groups separated, evolving in different ways.
Oh, that's so cool. It's like, who knew the ground could have such an impact?
It really is amazing, isn't it? This simple idea, continents moving, and it explains so much about life on Earth.
Makes you wonder, what if they stopped moving? What would happen?
That's a great question. Would evolution just kind of stop too? Or would life find a way to adapt?
It's something to think about, for sure.
It really is.
Well, that's the amazing thing about these deep dives, isn't it?
What's that?
We started with the Earth's core and ended up in the rainforests of Indonesia,
Quite a journey.
all because of this connection between plate tectonics and, well, everything alive. Hopefully everyone listening learned something new today.
And got that aha moment.
Exactly. Thanks for joining us on this deep dive. We'll see you next time.